Welcome to part 2 of Getting to Know the Common Core, with a focus on understanding the mathematical shifts. At Vista Unified School District, we like to focus on or start with our vision to be the model of educational excellence, with our mission to inspire each and every student to persevere as critical thinking individuals who collaborate to solve real-world problems. Our values of respect, trust, and collaboration will be emphasized throughout. So why do our kids need the Common Core standards? Let's take a listen to Jo Boaler as she points out why she thinks we need math changes.
In the current technological age that we live in, it's really important for people to be mathematical thinkers. You need it in every aspect of life. Not just numerical things like mortgages, but working with technology, working out all sorts of things. In many jobs also. I mean, they're predicting that in the next few years, 60% of jobs will need numerical comfort with numbers and mathematical reasoning, but only 20% of workers have that.
So keeping in mind that only 20% of our workers currently have the mathematical skills necessary to be in the workforce, we're going to focus on the 3 key shifts in mathematics. The first shift is focus, where our students need to have a greater focus on fewer topics. The second shift is coherence, linking topics and thinking across grade levels. And the third shift is rigor, with an increase in conceptual understanding, procedural skills and fluency, and application. So what did that look like for us in the 20th century math classroom? During that time, there was an emphasis on speed, with rote memorization being the focus and limited emphasis on conceptual understanding. Efficiency was also key, learning the standard algorithm and applying it over and over. And there was also a focus on accuracy, with an emphasis on the correct answer versus understanding the processes of how you got the answer. What does it look like today? We see a process-driven student where the answer is not the end result. Students must be able to make the math work using multiple dimensions, as well as understand why the math works. They have to be more collaborative, with a focus on sharing their own reasoning behind the processes. Students must talk about the why the math works and prove they know why the math works. The application is also important. Students should be able to apply their math to real-world situations and know which math to use for each situation. So when we look at the two side by side, we see that there is no longer an emphasis on speed, but more on a process-driven response. We no longer want our students to just give back to us the answers that we've already given them. We want them to be able to collaborate with students on multiple ways to solve problems. So instead of being answer-driven, we want them to be able to apply what they've learned and be able to give their reasons as to why the answer is correct. So that brings us to our standards, which we look at in 2 parts. The first part being mathematical practices, which are the same across every grade level. It's the how students learn to do math. In part 2, it's the mathematical content. It's the standards that are at each grade level and the what behind what students are expected to learn. So when we look at part 1, that's standards for mathematical practices, we're looking at the processes and the proficiencies that the students need to have in order to solve the problems. There are 8 proficiencies or practices that the students need to be able to use. The first being overarching habits of mind, the second steps being reasoning and explaining, modeling and using tools, and seeing structure and generalizing. An example of the first standard would look something like this.
What helped you keep going? Today on Teaching Channel presents Perseverance in Problem Solving.
What's the problem with this? Wheels are kind of falling off.
Students work in teams to build edible cars that really work.
Maybe we might have to sacrifice a little bit of design for functionality.
And design helmets to protect eggs, or should we say egg heads, as a way to study the brain.
And this is a great example of needing
learning to persevere?
These students practice perseverance as they solve a multi-step math problem.
I'm curious what your strategy is.
We'll cut it from this side.
Have you guys made a decision on how to group them?
Teamwork and planning are essential in this counting exercise.
And then we're going to count by 50s until we get our answer.
In this hour, we'll witness the sense of accomplishment that comes with hard work.
There you go. All right, let's get going.
Not everything in life is easy, so you have to keep working hard.
Is it okay to make mistakes?
Yeah. Let's go.
So in addition to the standards of mathematical practices, our students also have content standards. This is what the student should be able to understand and to do. These standards build upon each other, starting from kindergarten all the way through graduation. If you look here, it shows that students should be able to, in kindergarten, count, and then they build all the way up through numbers and operation fractions all the way through K5. Some of them build upon each other year after year. So what does that mean for parents, and how can you support your child with math at home? First, you want to become more familiar with the content, but know that you don't have to have all of the answers. Create more opportunities for math talk at home. Remember, it's the how students find the answers, not the what. And provide more opportunities for questions than answers when helping with homework. Some examples of questions you might ask at home would look something like this. What are you solving for in the problem? Or tell me what your answer means to you. If you'd like more information, there are several sources listed here to help you learn more about the shifts in mathematics or ways that you can help your students. We thank you for taking the time to support our students in learning about the shifts in mathematics. We can't wait to the next video. Thank you.